Alright folks, I got a little bit curious about the pattern that was going to be on this blade, so I went ahead and gave it a quick etch just to give me a feel for what the final pattern is going to look like. With this blade not being heat treated, the actual color and contrast of the pattern in the pattern welded steel is not what it's going to be once hardened. So a lot of guys will say, you know, don't etch your blade before hardening because you'll be disappointed in the results that you see. But I'll do it on occasion just to give me an idea of what the final blade will look like with the pattern in place. So right now I'm going to go ahead and fire up my vertical heat treat furnace, and I'm going to go ahead and tack weld a little washer on the end of the tang here so that I can hang the blade vertically in my furnace, and we'll go about heat treating the blade. Alrighty guys, I have my vertical heat treat furnace warming up. It's pretty well up to temp. PID controller hasn't been ran in a while, and I'm sure with the difference in the atmospheric pressure between Colorado and Michigan, it's struggling to dial in a little bit, but it's getting pretty close. I might have to adjust some of the tuning settings on it a little bit to get it to hold a little bit closer. Back in Colorado I was able to maintain about 1 degree within the set temperature. As you can see, it's got a couple wacky readings that are, I think, fooling it, but works pretty decent for what it is. Got the 2 burner set up, 2-stage, so when the solenoid opens it kicks the burners on high, and when it closes they still run at a very low temperature. As you can see, right now there's a little bit of a temperature differential between the bottom and the top of the furnace. I'm completely okay with that since I'll be using just the upper half for knives, but I can actually tweak and adjust the top and bottom burners with respect to each other and even that temperature differential out a bit. So depending on what I'm doing, if I'm doing a long blade, I can actually really fine-tune everything and get a nice even temperature along the entire length of this furnace. Or if at the moment I'm just running knife blades, you know, that upper section around this upper burner is all pretty close to uniform temperature. So I'm going to go ahead and stick a knife blade, that knife in there, get it heated up to roughly 600 degrees Fahrenheit, and then I'm going to bring it over here and apply some PVC anti-scaling compound. This is a product that Brownells makes. It's this kind of gray powder. You just heat the blade up, you know, about 600 degrees or so. Spoon some of this on. It'll liquefy and melt and cover the blade, and then you can go about your standard heat treatment procedures like you would on any other knife that you didn't use this on. And what this does is it coats the blade and prevents any oxidation from occurring. So you don't have to worry about scale buildup, you don't have to worry about decarburization on your blades. You just basically apply this, and the blade will go into heat treatment and come out of heat treatment basically in the same exact state and condition, at least in terms of the surface finish. No decarburization, no scale. Great product. I recommend it hands down. I will not heat treat a blade without this. I am definitely a firm believer in it. So if you haven't tried it, it's worth every penny. It's worth its weight in gold, so to speak. So definitely a good product. So I'm going to go ahead and stick that little knife in the furnace a little bit, get it heated up slightly, and then come over here and apply the anti-scaling compound. Alrighty, I've got this blade heated up. I'm just going to spoon on some of the anti-scaling compound, cover the entire blade. It's important to get really good coverage with this. Without good coverage, you'll have little spots that'll get oxidized and scale built up on them. So you want a pretty nice thick coat on any surface that you want to keep nice and clean and heat treatment. I even make sure I get it on the spine of the blade and everywhere. Alrighty, now that I've got a nice thick coat, I'll go ahead and suspend the knife in the furnace and get it up to temperature, so you can go ahead and do the normalization cycles. Alrighty, so I use a little welding rod just to bend and make a little hook, and that's what hooks into the end of my washer here on the end of my knife, and this allows me to hang and suspend the knife vertically in the furnace. And then from here it's just a matter of placing the knife in the furnace and positioning it right next to that thermocouple. That's going to give me the most accurate temperature reading. I've got my furnace turned up to 1525 degrees Fahrenheit, and this is going to be the first heat on my normalization cycle. Normalization is a process of taking the blade and heating it above critical temperature, which critical temperature is the temperature at which the actual microstructure, the crystalline structure of the atoms within the steel shifts and changes into a new lattice arrangement. I won't go too in depth into the metallurgy behind all of this, just because there's not really enough time on the video to accurately explain all of that. But what happens is, by heating the blade up to above critical temperature into a nice even heat across the entire blade, you are actually creating a very uniform grain structure and uniform microstructure within the steel. Throughout the forging process and throughout the grinding process, you're heating selective areas of your blade and working those, and you're actually imparting a lot of variation within the grain structure of the steel. So it's very important when it comes time to heat treat your steel that you are able to generate a nice even microstructure within the steel. In other words, you don't want a blade that has soft spots, hard spots, differing grain sizes throughout the length of the blade, as these can create structural deficiencies and performance issues in your finished product. So normalizing basically takes all that unevenness out of the grain structure microstructure of your steel and produces a really nice even microstructure throughout the steel, nice even grain size. The other thing normalization does is it helps to refine grain size. Throughout forging, you're heating your steel well above critical temperatures, and when you do this, this causes the actual grains within the steel to enlarge. So it's important to kind of repair those large grains through normalization before you actually harden the blade. So when I normalize a knife, I use a step-down normalization process that involves 3 normalization cycles. So my first normalization cycle, which is what I'm doing right now, involves heating the blade to slightly above critical. Critical temperature for the steel mix in this pattern welded blade is approximately 1500 degrees Fahrenheit. So that's why I've set my furnace at 1525, slightly above. This higher temperature allows all of your carbon atoms and alloying elements to go completely into solution at above that critical temperature. So it just helps helps ensure that you're getting that full effect of the normalization initially. My next normalization cycle will be right at critical temperature, which in this case will be 1500 degrees Fahrenheit. And the third normalization cycle will be at 1475, which is slightly below critical temperature. After this blade gets up to heat, I'll let it soak there for a couple of minutes, and then I will actually pull the blade out of the furnace and hang it and suspend it and allow it to cool in still air uniformly. You're not quenching this and you're not letting it cool really quickly. This just again creates a very uniform structure within the steel, and you're not really imparting any hardness properties or anything through normalization. So let this soak for a minute or 2 more, and then I'll go ahead and pull it out of the furnace and hang it and let it cool, and then prepare the furnace for the next normalization cycle. Alright, as you can see, the blade is up to a nice even temperature, so I'm just going to get a hold of it here and pull it out of the furnace. All that bubbling stuff on the outside is the anti-scaling compound doing its job, and I'm just going to hang this blade on this little stand here and let it cool uniformly in the air, as I mentioned previously. So again, this is just going to help create a nice even and uniform microstructure and grain structure within the steel, and help refine grain structure. So while that is cooling, I'm going to go ahead and come to my furnace here and tell it to maintain temperature at 1500 degrees, which is my next set point for my second normalization cycle, and the furnace will slowly cool itself off and reach that next set temperature. And once that blade has cooled down nicely, we'll go ahead and get it in there for that. Alrighty, so now the blade is roughly down to room temperature. It's to the point where I can kind of handle it by hand a little bit. Still a little bit warm, but that's okay. Probably a couple hundred degrees. Something I always try and check is to make sure that my blade hasn't warped. Sometimes due to retained stresses within the steel through the forging process or things like that, you can actually get some warps that develop on you during heat treatment. These of course are completely undesirable. You can correct them during normalization. You can also get warpage through uneven grinds due to uneven expansion and contraction, thermal expansion and contraction I should say. But if your grinds are nice and even and you did a quick flash normalization after forging, which I like to try and do. Most of the time you don't get much warping, if any. So this looks like it's maintained a nice straight nature, no warps. So we're going to go ahead and put this back in the furnace for the second normalization cycle at 1500 degrees. And the process is the same. Put it in, let it get up to temperature, give it a couple minutes to soak at temperature, and then from there we go ahead and pull it out and let it cool in still air. I don't actually want the thermocouple to touch the blade. I just want the thermocouple very, very close to the blade. So now that's in there getting up to temperature, and we'll go ahead and let it get up to temperature and give it a nice soak and pull it out. Also, I've started setting up my quench setup. I've got a little electric griddle here, and I set my various quench tanks on top of that. In this case, I'm going to go ahead and do a vertical quench. I also have a pan that goes on top for horizontal or edge quenching, but since this isn't being differentially hardened or anything like that, I do like to do a vertical quench just because, again, that warping issue is minimized or reduced when you're using a vertical quench versus horizontal quench. You know, with a horizontal quench, if you happen to plunge your blade in at a slight angle, that rapid contraction on the one side can pull your blade out of true. So it takes a lot of practice to do your horizontal quenching to make sure that you're completely perpendicular up and down with your blade and not canted to one side or the other. Like I said, with a vertical quench, you kind of have gravity helping you, and if you're, you know, offset in any direction, it's not really a critical problem. So I got the oil heating up here on this just because it typically takes it a while to get up to temperature. I quench in mineral oil, and I usually try and heat the oil to approximately 130, 140 degrees Fahrenheit. Heating the oil actually increases the speed of the quenchant, so it actually reduces the viscosity of the oil and allows the oil to flow and remove heat more effectively from the steel through convection. So it's almost counterintuitive that a warmer oil would actually cool steel faster than, say, cold oil, but it is the way things work. So I'll let that heat up while this is normalizing, and keep an eye on the temperature of that, and it should roughly get up to temperature right around the time we're ready to harden this blade. Alrighty, so I've had the blade in there soaking for a few minutes. As you can tell, it's up to a nice even temperature at 1500. So I'm going to go ahead and pull this blade out and set it off to the side just like before. And we'll let it cool uniformly in still air. Now you can see how the areas that I coated with the anti-scaling compound almost have a wet look to them, and the areas on the tang that I didn't coat actually have a scale building up on them. Of course, the tang is not that important. It can get scale on it. That's not going to adversely harm the blade, but the areas with the anti-scaling compound remain coated and no oxidation occurs. And after heat treatment, all I have to do is take this blade and put it in some hot water, and the anti-scaling compound will actually dissolve away, and leaving a nice clean blade. So we'll go ahead and let this cool in still air, and once it's roughly 200 degrees, somewhere in there, we'll put it back in for the final normalization cycle. And while that's cooling, I'll go ahead and turn the furnace down as well. The third normalization cycle will be at 1475 degrees Fahrenheit. Alrighty, the blade is cooled down again, back close to room temperature. So we're going to go ahead and put it back in the furnace, 1475 for the final normalization cycle. And we'll go ahead and adjust it so it sits right next to that thermocouple. Right there, and let it get up to temp and let it soak, and the oil is slowly heating up. Got my little thermometer there. As you can see, we still got a ways to go before we get it up to 130 degrees, but it'll get there soon enough. So let that soak and pull it out and do the final normalization, and then we'll be ready to turn the furnace back up to 1500 degrees for the hardening heat. Alrighty, blade has been soaking in there. It's up to a nice even temp. So just as before, we're going to pull it out, hang it up, and let it cool uniformly in still air. And that'll be the final normalization cycle. So once our oil gets up to temperature here, then we'll go ahead and of course, once the blade cools down, we'll go ahead and turn the furnace up to 1500 and heat the blade back up, and then we'll quench it in the oil to harden it. Alrighty, blade is cooled. Got the furnace reset to 1500 degrees. So we'll go ahead and put this knife in there for its final hardening heat. I got the quench oil up to temp roughly also. Get the knife set in there close to the thermocouple. As you can see, we got the oil temperature at about 150 degrees, which anything between 130 and 160 is just fine. And of course, by the time this gets up to heat and soaks, that'll probably drop down closer to 140, so we'll be set with the oil. And as soon as that blade gets up to temp and soaks for a few minutes, we'll go ahead and do the hardening quench. There we go. There's the hardened blade. Just let it cool a little bit more in the oil. Pull a little bit more heat out of it.